Okay, so now I want to talk to you a little bit more about the ones that you can do and then the ones that you couldn't do on 11.3, I believe it was, and why you couldn't do them. Okay, so here's one that you should be able to do. Okay, this is a regular hexagon. So we're going to start out with a regular hexagon. So not only is it equilateral, remember it's also going to be equiangular. And we can actually figure out what the measure of each of those angles is. And the reason we might want to know that is maybe you have something like here, and let's say, let's just say we're given that this is 5, this little piece right here. So of course we know that the length of every side of our hexagon is 10 right away, but we need to know the length of the apothem, and we need to be able to figure out what that is. Okay, and so if we draw in a triangle, we know we have a right triangle, but what kind of right triangle is it? That's really the important part. Okay, so let's think about this for a minute. We know that 180 times the number of sides subtract 2 is the sum of all the interior angles in a regular, in any polygon. Okay, well, I guess I should say a convex polygon. So in this case we have 6 sides. Subtract 2 is 4, and then 4 times 180 is 720 degrees. So that's the sum of all of our angles. And if we divide that up, now remember it's equiangular, isn't it? Okay, so if we divide by 6, that gives us 120 degrees. 120 degrees for each of our interior angles, including this one. And remember, our radius is an angle bisector. And so I'm going to say that one's 60, and of course we have 60 over here too, which I don't know if that matters, but it is an angle bisector. So now, what type of triangle do we have in this regular hexagon? Well, we have a 30, 60, 90 triangle, don't we? And that, again, that's a special right triangle that you guys can handle. So we have the short leg as 5. Okay, well, I think we can figure out what the long leg is. It's 5 radical 3, isn't it? Okay, or let's make this a little more interesting. Okay, let's say they gave you the apothem in this case as 5, and then you've got to figure out the length of the side right here. Well, this is going to make the cheese a little more binding, isn't it? Okay, we've got to go from the long leg to the short leg. Well, we've got to take 5 and we've got to divide by radical 3. Now remember, that's not simplified. We need to get rid of the radical in the denominator, and so we're going to multiply by radical 3 over radical 3, and we end up with 5 radical 3 over 3. So 5 radical 3 over 3 for the length right here. Now we need to know the length of that entire side, and so if we take 5 radical 3 over 3 and we double that times 2, we simply end up with 10 radical 3 over 3. Nothing reduces or anything like that. And so, okay, now we know the apothem is 5. We know the length of one side is 10 radical 3 over 3. We know we have 6 sides. We can find the area. So the area is 1/2 of the apothem, which in this case is 5, times the number of sides, which is 6, times the length of one side, which is 10 radical 3 over 3. So remember, on the one where it says the perimeter, 1/2 the apothem times the perimeter, the number of sides times the length of one side, that is the perimeter. It's the same thing. Okay? So I'm going to think of these all as fractions. Okay? Before I multiply this out, I'm going to reduce. 3 goes into 6 twice. 2 goes into 10 5 times. And now let's see if I can do this right. It looks to me like we just have 5 times 2 is 10, times 5 is 50, and then we have times radical 3, and that would be in whatever square units we happen to be talking about. So if this were 5 inches, this would be 50 radical 3 square inches, and once again, that's the exact answer. I don't need to get out a calculator and change that unless I'm asked to give the answer to the nearest tenth or to the nearest hundredth or something like that. So I'm just going to give the answer like this. Now, let's see, what's the other time we'd be able to use this? I think, if I can find it here, I have an example of one where we have actually a square. And when we have the square and we draw the apothem in, and then we draw the radius in, because these are each 90 degrees, and the radius is an angle bisector, we end up with a 45, 45, 90 triangle. Okay? And again, a 45, 45, 90 triangle is a special right triangle that you can deal with. So if you knew the radius, if you knew the apothem, if you knew the length of one side or half the length of one side, you could work that out and you could do this. Okay? So I guess now we have to talk about why we can't, or what would happen and everything like that. So let me just quickly draw my best pentagon, regular pentagon. Okay. Hope that looks okay. Here, I'll fix it up for you a little bit. Okay. With the pentagon, we have, let's see, the number of sides, subtract 2 times 180. Okay, so that's 3 times 180. Are you thinking? So we have 540 degrees right there, and then we divide that by 5, and we have 108 degrees in each of our angles. Okay, so each angle here is 108 degrees. So if I draw a radius in, well, I'm going to get a triangle right here, and this angle is going to be half of 108, which is 54 degrees. 54, 90, and then what's the other one got to be? Right? It's not going to be a pretty thing, is it? Okay, it's just 36, so 36 degrees right here. Now a 36, 54, 90 triangle is not a special right triangle. It's not one that you know all the relationships to. Now, do mathematicians, as you get a little bit older? Yes, you do. Okay. If we ever get back to school before the end of the summer starts, you will as well. But we haven't had time to do this yet. But all these triangles, regardless of the measure of the angles, if they're right triangles, we know the relationship between the legs and the hypotenuse, and we can work that out. Just you can't yet. So that's the reason I told you didn't have to do those. And that's something you might want to look out for on the mid-chapter quiz. And I want a specific reason, if you run into this, why you can't do that problem. Not just, oh, I can't do that one, or you leave it blank. I want to know that you listen to the video and you understand why you can't do that problem. Okay, good luck.